Welcome back to the Comedy Recycling Theory. Today I'm going to do a very brief segment, or at least it may be brief, on is our universe really only about 13.7, 13.8 billion years old? Well, according to the Comedy Recycling Theory hypothesis, our universe is actually infinitely old. Now, it doesn't appear that way. It appears it's quote-unquote svelte and youthful 13.7, 13.8 billion years because our universe does recycle both matter and energy, and that since the energy content of our universe is fixed by the Comedy Recycling Theory hypothesis, and that it's contained within an area the size of our entire universe we call the active zone, but it's fully closed, it's fully closed off at all of the outer edges, which means that the energy content, the mass content is fully stable, that the density is stable, that it never collapses, and that because the matter is more downhill or lower energy at the outer edges, that the matter cannot fall inwards towards the center of the universe without gaining energy, which it does not have. So that makes our universe incredibly stable, both size-wise and content-wise. So the real hypothesis is our universe only 13.8 billion years old? Now, the conventional theory says that the 2.7K microwave radiation that's observed coming equally from all directions is the redshifted remnant of the Big Bang. The Comedy Recycling Theory, on the other hand, says that 2.7K is merely the averaged out remnants of nova, supernova, quasars, Seyfert galaxies, gamma ray bursts, and the like, and that although it's not easy for right now to do it, one of the best ways to tell would be come back in like 1.3 billion years, and we'll just measure the 2.7K from Earth and see the 2.7K by the Comedy Recycling Theory hypothesis will measure exactly the same, or virtually exactly the same, in 1.3 billion years. Now, unfortunately, you have to wait quite a while to be able to check that, but that is part of the Comedy Recycling Theory hypothesis, that we could do that. I don't know what the quickest we could do with any precision of measurement would be. What's the shortest amount of time we could actually tell the difference between is the 2.7K that we observe in the universe actually redshifting or cooling down with time? That, according to the Comedy Recycling Theory hypothesis, it's not doing so, because our universe is not expanding, because our universe did not begin from a Big Bang. That the 2.7K is more like a roar of a giant waterfall. If you were close to a waterfall like Niagara Falls or some other major waterfall and you get close to it, you hear that roar when you get close to it. That seems to come from the vicinity of the waterfall. Now, again, it's not quite the same thing because we're seeing this 2.7K coming from all directions, but it's a similar process that's creating it. It's just averaged out noise, averaged out reactions that are going on all around, and that will always be there. It never redshifts with time. It's not cooling down. It's not redshifting with time. And that's part of the Comedy Recycling Theory hypothesis, that if you come back, like if our universe is 13.7 billion years old now, and you come back in 1.37 billion years, will the 2.7K radiation be at least 10% redder if you wait 10% of the time that our universe supposedly or 10% of the supposed age of the universe, and come back, that the 2.7K should be that much redder, that much cooler? And the Comedy Recycling Theory says that will not be the case, because that's not what's producing the 2.7K radiation that we measure. It's merely a natural byproduct of the processes that are going on from energy generating and energy recycling within the universe already, and that it has nothing whatsoever to do with the remnant from, or the energy remnant from the Big Bang. And that's today's segment on the comedy recycling theory of the entire known universe.